Alright, so some examples of functions that are even. Can somebody give me one? That they look the same? That's actually this. Did you know that? What do we call that? Yeah. Now here's why this is, remember this little definition I told you? If you put in -2, what would it output? +2. If you put in +2, what would it output? 2. Do you see how when I put in -x, I got the same as +x? Okay. Or looking, I'm going to just do this. X comma y is also -x comma y. Reflection symmetry. Isn't x squared also even? Yeah. And it's the same reason. What would happen when you would square, well, let's take 4 for instance. What's 4 squared? 16. What's -4 squared? 16. F of -x equals f of x. Okay. I'm going to give you one more. I don't know if you knew it or not. You should know it. I was actually in some of your classes when you were studying this last year with Mr. Stallman. Does anybody know what this curve is? Which one is it? Okay, cosine. Okay, cosine is an even function. Cosine starts at 0, 1, and if you put in values of +x, they are the same as cosine of -x. Okay. All right. That's even. Let's talk about odd functions. Okay. By odd functions, I don't mean strange. No laugh? No laugh. Okay, here's the definition of an odd function. This time when I put in f of -x, it outputs -f of x. And that might be harder for you to understand. What's the difference between that? I don't get that. Okay, I'll show you. I know it's an odd power, but I'm going to use this one first. X cubed looks like this. I can. I'm going to use the example of the point 2, 8. The point 2, 8 is on this, and also the point -2, -8 is on there. Okay, so here we go. I have 2, 8. When I take -f of x, when I put in -2, it gives me the opposite y value. Okay. In geometry, what kind of symmetry did we say this had? Not reflection, but what? Another R word. Good. Odd functions graphically have rotation, symmetry, about the origin. The origin is what point? Okay, now this is important because there's things that have rotation symmetry, but they're not about the origin. If I had moved the x cubed graph like up over here, that has rotation symmetry, but it is not odd because it's not about origin. Trying to think of another one that's odd. Oh, let's do this. Sine. Sine is an odd function. Can I squeeze it in the bottom here? I think I can. So sine goes through 0, 0. Do you see how this kind of hump of the graph also happens down over here? Okay? And even if you would want to turn your notebook all the 180 degrees, it looks the same. Okay? So sine is an odd function. Okay. So now that's how you look and tell. I'm going to show you an example of how to use each test. Okay? So we are going to take a look at the following functions. So I'm going to say, are the following functions odd, even, or neither? Because some graphs don't have reflection symmetry or rotation symmetry. F of x equals x squared plus 5 is my first one. Here's how you use these tests. You actually use, for even, just to remind us, you actually put negative x in for x in the function, and you try to show how it gets back to the original. Okay? And so here's what I'm going to write down. F of negative x equals, by the way, I'm guessing it's maybe even because it's a parabola. That's my guess. If I put negative x and replaced x with negative x, wouldn't it be negative x parentheses squared plus 5? What happens when we square negative x? Okay, so then it goes, I'm going to write equals x squared plus 5. Didn't I just show when I put negative x in, I got the same thing as f of x? Okay. I just showed that this is even. Cool. So I'm thinking parabolas are even. So let's look at this one. G of x is x squared minus 3x. And obviously you could go and graph it, take a look too, but I'm just going to do it algebraically. Okay, so let's see what happens. I'm going to put g of negative x in. So instead of x squared, I have negative x, close the parentheses, squared, minus 3 times, instead of x, I'm going to write negative x. Now let's simplify. What happens when I square negative x? Isn't it positive x squared? How about this? Minus 3 times negative x, what would happen there? Plus 3x. Uh-oh. Did this go back to the original? No. This is a even, is it? Shoot, I wonder if it's odd. Did it change the signs of the whole thing? Did it change the signs of both things? No. So guess what? Neither. So I'm going to write not equal to f of x, not equal to negative f of x, just so you're understanding why. So this is neither. Okay. Do you want to see one that's odd? Because I haven't shown that. Okay. So, well, I know I told you it's odd now, but how about h of x equals x cubed plus 7x? Okay. Now, I'm just going to tell you this. If I told you, hey, tell me what the opposite of h of x would be, would you agree with me it would be negative x cubed minus 7x? Okay. So what I'm going to do is the same thing. I am going to put in negative x for x. So I have negative x parentheses cubed plus 7 times negative x. That's a good question. Good. Yeah. Think of it as the opposite sign. Yep. You mean if it was like negative x cubed minus 7x, then the opposite would be positive. Yeah. All right. So when I squared this, it became positive, but I cubed it, so now it's still negative. And 7 times negative x is this. Do you see how it changed the sign of the whole function? This. Oh, no, you don't, because you can't see it. Okay. Do you see how that was positive and now it's negative, that was positive, now it's negative? What that means is when I put negative x in, it made the function the opposite. That was our definition for being odd. So this is odd. I always run out of time in here because I just think everything is so important to talk about. I had written these on your previous page, but I just put them at the top of this page to remember. That's what it means to be odd, and so that's why I was showing that was odd. Okay. I know that we have been taking a lot of notes right now, so